In my previous video I had said when fz is analytic, then integration along this contour C always would be 0, and when fz is not analytic along this contour, then what I will do, in my previous video I had seen also, and in my previous video I had seen integration dz over z minus a, where C is any simple closed curve. If z equal to a be the outside on this circle, then by Cauchy's theorem we can tell this is always be 0. And when z equal to a would be inside the circle, then integration along this curve, this value would be 2 pi I. I had seen dz over z minus a, this value is 2 pi I. Because at the point z equal to a, the function is not defined. Means the function is not analytic at the point z equal to a. But today I will see dz over z minus a to the power n, where n equal to 2, 3, 4 up to so on, where z equal to a is the inside of this circle, then also this value would be 0. And when outside of a is outside of the circle, this is obviously 0. But this is very important. When n equal to 1, then this value is 2 pi I. But when n equal to 2, 3, 4 up to so on, then this value would be 0. Now I will see this integration. This is the picture, this is the A point, and A is the inside of this circle, and this radius is epsilon and the angle is theta, and the point Z is here. This distance from origin to Z is here. Then Z minus A is epsilon e to the power I theta. That imply z equal to actually a plus epsilon e to the power I theta, then dz equal to epsilon times I e to the power I theta d theta. Now put the value in integration. Here this integration 0 to 2 pi dz means epsilon I e to the power I theta d theta, and z minus a to the power n means epsilon to the power n e to the power I n theta. Then this value would be I over e to the power epsilon to the power n minus 1 integration 0 to 2 pi e to the power 1 minus n I theta d theta, and antiderivative of this integration is e to the power 1 minus n I theta over 1 minus n I. This is the antiderivative, and here also I times I over epsilon to the power n minus 1. And we have to find antiderivative at the point 0 and 2 pi, and this value would be at the point 2 pi this value is 1, and at the point 0 this value also 1. So value of the integration would be 0. I hope my all viewers have understood this value of integration. Okay? That means when fz equal to 1 over z minus a, then integration dz over z minus a, this value is 2 pi I, and integration dz over z minus a to the power n when n equal to 2, 3, 4 so on, then this value would be 0. And this result is very important result for higher study. Okay. Next, I will say some more example of Cauchy's theorem, because Cauchy's theorem is very useful result for complex analysis. And this is, if you know the Cauchy's theorem, then you can easily solve any integration. Let's see the question. Now evaluate the integration z square minus z plus 1 over z minus 1 dz on this region mod z equal to half. For this, notice here z equal to 0 and mod z equal to half radius. In this region, the function is not analytic at z equal to 1, and this point is outside of this region. So, by Cauchy's theorem, we can tell inside of this region, the value of integration is equal to 0. Another type of example, evaluate the value of integration where fz equal to z square z plus 4 over z square plus 2z plus 5. On this circle, absolute value of z plus 1 equal to 1. Notice here z square plus 2z plus 5 equal to 0. That means z equal to minus 1 plus 2i, comma minus 1 minus 2i. At this point, function is not analytic. But next question, is this point is outside or inside of the circle? Here the circle is absolute value of z plus 1 equal to 1. Now put the value of z. Absolute value of z plus 1. If we put the value of z, then this value would be minus 1 plus 1 plus 2i. This value is equal to 2, which is greater than 1. So, absolute value of z plus 1 is greater than 1 if we choose the point minus 1 plus 2i. That means this point is outside of this circle. That means in which point the function is not analytic. This point, both points similar to before, this is also this is outside of the circle. That means this function is analytic within the circle. So by Cauchy's theorem, we can tell value of integration would be 0. I hope my all viewers have understood this is clearly. Okay. Well, next I will say what is the Cauchy's integral formula. Till now I had seen, assume f is analytic within and on the closed curve C, and A is enclosed by C. Then integration along this contour, say fz dz equal to 0. Also I had seen integration along this contour C 1 over z minus a dz equal to 2 pi I. Till now I had seen these two parts. Now I will say the Cauchy's integral formula. At first, say what is the statement of Cauchy's integral formula. If fz is analytic inside and on a slim pill closed curve C, and if A is inside this contour C, then integration along this contour C fz over z minus a dz equal to 2 pi I f. That means by Cauchy's integral formula, values of the function at all points along the boundary curve is equal to f of a, means the value of f at a point inside the contour C. And this is the values of the function f at points along the boundary curve. I hope my all viewers have understood this is okay. And the proof is such type integration fz dz over z minus a. We can write this as integration f of a divided by z minus a dz plus f of z minus f of a divided by z minus a dz. We can write this as. And consider this integral as I1 and this integral as I2. Then I1 means, since f of a be a constant number, so this would be cancelled from integration. F of a times integration dz over z minus a. And integration dz over z minus a means this is equal to just 2 pi I. Next, to prove the integration, this value of the integration is f of a times 2 pi I, we have to prove I2 equal to 0. For this is deform the curve C into C delta, because this is the simply connected domain. C is so we can sink this at a point. So deform C into C delta. Since f is analytic everywhere on this domain, f is analytic within on a closed contour C on the whole point only except the point A, so we can shrink this as C delta. Since fz is analytic around the point A, so we can choose one delta radius. We can choose one delta radius around the point A such that absolute value of fz minus absolute value of fz minus f of a less than epsilon. That means for any epsilon we can choose one delta such that distance between fz minus f of a less than epsilon. This is true for any small epsilon greater than 0. For any epsilon always I will get one delta, because the domain is simply connected domain. That means modulus of I2, which is equal to modulus of fz minus f of a, and this value less than epsilon over z minus a. Okay, and this is true for all epsilon. For all epsilon always I will get one delta, so this value is equal to 0. Therefore I have proved this value is equal to 0. That means only the value is f of a times 2 pi I. Now I will see integration e to the power z over z square plus 1 dz along the contour mod z equal to 2. And notice z square plus 1 means z equal to plus minus I. Very interesting here. Consider just 3 curves, because Ez over z square plus 1 means z plus I, z minus I. And Ez over z plus I, this function is analytic at z equal to I. And Ez over z minus I, this is analytic at z equal to minus I. So the picture would be such type. The picture would be, here the point I in y axis and here the point minus I. And consider this is the contour C1 and this is the contour C2. In C1, this function is analytic, and in C2 this function is analytic. And in mod z equal to 2, this is actually C3, in which I and minus I be the singular point. So for this, the curve C1 e to the power z over z plus I over z minus I, this value would be 2 pi I. At the point I, this value would be e to the power I over I plus I. So this value would be e to the power I, 2 pi I over 2I, this value would be pi I. and along the curve C2 integration e to the power z over z minus I over z plus I, this value would be 2 pi I e to the power minus I over minus I minus I. So this value would be minus pi e to the power minus I. I hope my all viewers have understood. Now we have to find integration along the curve, actually mod z equal to 2. And in mod z equal to 2, there exists two analyticity at the point I and at the point minus I. So now we can just connect these two contours by Cauchy-Gaussian theorem. By multiple connected Cauchy-Gaussian theorem, we can shrink, we can deform these two contours such type by this path, by this direction. Then integral along C3 means mod z equal to 2 fz dz, this value is equal to integral along C1 fz dz along C1 plus integral along C2 fz dz. I hope my all viewers have understood. And this value is along C1, this value is pi e to the power I, and along C2 this value would be minus pi e to the power minus I. So this value would be pi times e to the power I minus e to the power minus I. I hope my all viewers have understood this integration. Okay? Oh. Second example, integration sin pi z square plus cos pi z square over z minus 1 times z minus 2 dz. And we have to find the integration along mod z equal to 3. Here notice, in this function is not analytic at the point 1 and 2, and at 1 mod z equal to mod 1, that means this is always less than 3, and another point z equal to 2 and mod z equal to mod 2, which is 2 and 2 is less than 3, that means 1 and 2 both lies within the circle. So similar to before, we have to find integration along this contour C, means we have to find integration along the contour C1 plus integration along the contour C2. I will here use just together integration along the contour C1 means, at first integration along the contour C means integration along the contour C1, where C1 means sin pi z square plus cos pi z square over z minus 2 over z minus 1, plus integration along the contour C2, this here dz, this means sin pi z square plus cos pi z square over z minus 1 over z minus 2 dz. I hope my all viewers have understood. Here for short calculation I have used this plus in together, and this value would be C1 means we have to find z equal to 1. Just put the value z equal to 1. This is 2 pi I f of a means sin pi plus cos pi over, put the value 1, this value would be minus 1, plus put the value 2, this value would be sin 4 pi plus cos 4 pi, and put the value 2 here, 2 minus 1, that means this would be 1. So these value, we all of us know, sin pi means 0 and cos pi means minus 1. So this value would be minus 1 and here also minus 1. So minus 1 and minus 1 cancel, this value would be 2 pi r. Similarly, sin 4 pi is 0 but cos 4 pi is 1. Here also would be 2 pi I. Sorry. So this value would be 2 pi I. So actual this value along this contour C, this value would be 4 pi I. I hope my all viewers have understood this type of integration. This type of integration actually very important for higher study, also for any competitive exam. Okay? I will stop here. In my next video, I will discuss differentiation of Cauchy integral formula. Okay? But today's topic is very important for higher study. So at first I will highly recommend you please see today's video with pay attention. See you soon, stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.